In this video, we'll be looking at how to find the volume of a solid of revolution using the shell method. Here we have a picture of a solid formed by revolving about the y-axis, and we have concentric shells, the outer shell here with this representative rectangle, and then the next one inside, and then the next one inside, and so forth. It's like a jelly roll type thing. Well, if we take this outer shell and we cut it down the side and spread it out, then we have this rectangular prism. And we know that on this rectangular prism, the length here is the same as the circumference here, which is 2 pi r. So this dimension is 2 pi r, and then this height of our width of our rectangular prism is the height of our function, and then the thickness of the shell right here, which is going to be very, very small, that's our dx. So for this solid, the volume of the shell is given by this formula, the integral from a to b, and a is my inner radius, the distance from the inner point to the axis of revolution, and b is my outer radius, so the distance from this outer point to the axis of revolution. And then we have 2 pi r of x, h of x, dx. If I have a horizontal axis of revolution, then my picture looks like this. Again, I have the jelly roll appearance, the integral from c to d, and this time c and d are values over on the y-axis. So the integral from c to d of 2 pi r of y, h of y, dy. Notice on this one up here, my radius changes as x moves from a to b. So x is moving from a to b, so my radius is what's changing when we integrate. And then on this, my radius changes as y moves from c to d. Also, notice the representative rectangle is parallel to the axis of revolution when you're using the shell method. So we're moving our representative rectangle on this one from C to D, so it's moving along like this, and it is parallel to the axis of revolution. Let's do an example. We're asked to find the volume of the solid formed by rotating the region bounded by x minus 2y equals 0 and y equals x squared over 8 about the y-axis, and use the shell method. So x is 2, I have 1/2. If x is 4, I have 2. So I have a parabola that this one is x equals 2y, or y equals 1/2 x. So I'm revolving about the y-axis. My axis of revolution is vertical, so my representative rectangle will be vertical. This is parallel to the axis of revolution, and it's moving from 0 to 4. So I have the integral from 0 to 4 of 2 pi r, and then r is my x value, and then my height of my rectangle is the upper function minus the lower function. So my upper function is the line 1/2 x, and my lower function is the parabola, which is x squared over 8 dx. Alright, we can take the 2 pi out in front of our integral. And let's distribute here. We have 1/2 x squared. And then when we distribute here, we have x cubed. I'm going to separate my number, so 1/8 x cubed. Alright, so when I integrate, then I have, this will be x cubed over 6, subtract x to the 4th over 32, from 0 to 4, and then we have 2 pi. When we do the math, put the 4 in first, and do the math, and then subtract from that what we get when we put the 0 in. We'll get 8/3. So this is 16 pi over 3.